Okay, so this is 6.2b on page 29, and we are dealing today with the quantity which is charge and the quantity which is current. And the symbol for charge is Q, and the symbol for current is I. And I know you're probably like, what the heck? There's no Q in charge, and there's no I in current. Well, Q stands for the quantity of charge, and I stands for the intensity of the current. And if you look on your data sheet, let me see if I actually have this in my data pages. Was I clever enough to have done that? No, I was not. See if I have it last year. No. Oh, well, that's okay. I'll get it up and running soon enough. That's fine. There we go. So we're dealing with charge and with current. In a metal, what are the charges that flow? Electrons. Okay, and we are mostly going to be dealing with electrons in this electricity unit. But electrons are so very small that it is very inconvenient to count them one by one. You're not going to be like 1 electron, 2 electrons, 3 electrons. That's crazy. And in the electricity unit, we often compare the flow of electrons to the flow of water because we're used to seeing water flowing, right? We see water flow in rivers and that sort of thing, but we can't actually see the flow of electrons. So we very often compare them. So we're comparing the flow of electrons to the flow of water. Now, you might measure water in buckets. Okay, so we might have a bucket of water. All right, so what we're going to do similarly is we are going to measure our number of electrons in buckets of electrons. Now, this is just an analogy. Do you guys know what an analogy is like? What an analogy is? An analogy is where you say, this thing is like that thing, and so we can imagine it that way. This thing is like that thing, so we can imagine it the same way. Jerry, can you come sit here, please? Why? Because I hear nothing but your voice. Okay? So we can imagine that thing in this way. This is like the stupidest sentence ever. Okay, so what we're saying is a bucket of electrons is like a bucket of water. That's better than any sentence I've made over here. Okay, that sentence, you can just leave that to the side because I don't know that it makes any particular sense. But here you can see we have our little electrons. There's an electron, there's an electron, there's an electron. They're kind of dark, so you can't really see, but they all have little negative charges on them. Okay. And this bucket of electrons has a label on it, and that label is 1C. C is the unit of charge. Jerry, come sit over here. I'm still hearing your voice, though. Do you promise? But last time people promised something in this class, they said, I promise I will not be an idiot and spray my partners with water. And so what did they do? They went out in the hallway and then they sprayed their partners with water. Yeah. So the promises are not so much, like I'm not feeling promises. Cross your heart, hope to die? Okay. C is the unit of charge, and it stands for Coulomb. C-O-U-L-O-M-B. And the OMB is like a comb. Okay, it's pronounced like comb. And the coup, so it's Coulomb. Coulomb. A coulomb. And the accent's on the first syllable. Okay, a coulomb. Each bucket of electrons, which is 1 coulomb worth, contains 6.24 times 10 to the 18. And if you know anything about scientific notation, you'll know that that means we have 6.24 times, and then we have a 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, gosh, this is tiring, 13, 14, 15, 16, 17, 18. So we have 6.24 times 10, 18 times, okay? And that equals, let's see, that's millions, billions, trillions, quadrillions, 6.24 quintillion electrons. 6.24 quintillion electrons. That's a whole heap load of electrons. Can anyone envision how many that is? Can anyone picture that? No, I can't either, which is why we're going to envision it as a bucket of electrons. And there's just lots of electrons in there. Okay? So our bucket of electrons contains a whole heck of electrons. So a coulomb is a bucket of electrons. That one I want you to stick in your head and remember that. A coulomb is a bucket of electrons. It is a measure of charge. Unit to measure charge. And what is the symbol for charge? Do you guys remember? Q. It stands for quantity of charge. Okay, excellent. Page 30. Let's go to the bottom of page 30 where we have the little river and number it page 30 if you have not done so already. Okay, and here we have our little summary here where we have our quantity is charge, and it's the letter that stands for it is Q, and the unit is coulombs, And what is a Coulomb? It's a bucket of electrons, and its symbol makes a lot of sense. It is a capital C. Okay, so that's a capital Q and a capital C. And if you wanted somewhere to make note of why it is Q, Q stands for the quantity of charge. So Q stands for the quantity of charge. Okay, so that takes care of charge. What is current? I'd like you to describe to your neighbor what does current mean to you? Like if you're talking about the current in a river, what would that mean? In a river, the current is basically how fast the water is moving. What do you think we're looking at moving in electric current? We're not looking at water, we're looking at electrons. Okay, so a current is a rate of flow. How fast a substance flows, moves in one direction. So that is current. And you can see here we have a lovely little mountain scene with a river, and we have the current flowing down there. And presumably, you could measure this in buckets that flow past a point per second. Okay, so we could measure the buckets of water per second that flow past a certain point. Buckets per water per second that pass a certain point. So you might be like, oh, that's 10 buckets and another 10 buckets and another 10 buckets every second. So that would be 10 buckets per second. But of course, we are doing electricity, so we are not measuring buckets of water. We are measuring the flow of charge, so we will be looking at buckets of electrons. So we're now on our next page that says current at the top. You are going to go down to the bottom of the page and label that 31. In this case, our quantity is current, and it is represented by the symbol I. And if you're wondering why I, does it say here? No, it doesn't. So let's write it in. I stands for the intensity of the current. Has anyone heard of an amp as a unit? A few people, okay. Amp is the unit in which we measure current. So we say, how fast is it flowing? You have a current of 4 amps. If it's flowing faster, you might have a current of 6 amps or 12 amps. Okay, that's how fast the charge is flowing. So the unit is amps. Now, amps is actually short for something else. You might also hear it referred to as amperes. If you want to be French about it, you can call it, say, amperes. But generally in English, we say amperes. But amps is good. And we abbreviate it even further to the letter A, which that one makes also like nice sense. Okay, ampere A. So current I, is the rate of flow of electrical charge Q. So there is a relationship between the charge and the current. So here's our little river analogy. If we are measuring current in a river, then we're measuring how much water passes a point in a second. And so our unit would be buckets of water per second. Does that make sense? Buckets of water per second? But if we're measuring current in electricity, I, it's how much charge passes a point in a second. So the unit of charge, what's the unit of charge? Coulombs, which is C. Okay, so we're going to have buckets of electron per second. So a bucket of electron is a coulomb, so it is coulombs per second, or C over S. And I'm going to rewrite this as coulombs per second, but it's okay to write it like the little slash way as well, okay? And if you can imagine this, here we go. You can imagine if these buckets were moving, you could actually count them as they go past, right? You could be like, oh, that's one bucket. You could watch them. 1 bucket, 2 buckets, 3 buckets, and you could time it, right? For maybe 10 seconds, and you could say, oh, in 10 seconds, 3 buckets went by, so it's 3 buckets in 10 seconds, and so on and so forth. But scientists, they like to simplify things, so instead of writing coulombs per second, they like to shorten it to amps. Amps are the same as coulombs per second. A coulomb per second is an amp. Okay, they are literally exactly the same thing. So you can substitute one for the other. So if you find your answer is in coulombs per second, you can then change your answer to amps. And here is our current formula. Current is the amount of charge. And this is now on page, and you'll see this little chart here, and we've got this guest cub stuff at the bottom, and this is now page 32. So you'll want to number that at the bottom. Yes. It's like 50 amps, yes. Okay, yeah, good question. So current, we're measuring the amount of charge in a given amount of time. So it's charge divided by time. Now, what if we want to write that as a nice little formula? So we can use our guest cubs method, our equation. And if you're into memorizing this, I call this the I quit equation, okay? And you can be like, I quit, right? Because the Q goes over top of the T. So you say, I quit. I quit. And that's how you can remember it. So it's your choice whether you use the purple sheet that has the I equals Q over T on it, or whether you memorize that formula, okay? This is known as the I quit formula. Okay? And just because we're going to make sure we understand everything, we've got our quantity is the intensity of the current, and the symbol is I. The unit is the ampere or the amp or the coulombs per second. We can abbreviate that as A, or we can abbreviate it as coulombs per second. Quantity of charge is Q. Its unit is coulombs, abbreviated C. And of course, we all know already time, little t. Remember, time is lowercase t. Okay, and we measure that in seconds, and it is S. So now we are going to use guess cubs to solve a problem. So we are going to identify our given, and remember the given are things where the numbers are in the question. So see if you can find numbers that are in the question. What have we got? Yes. We've got 12 coulombs, and it tells us right there that that is the charge. What is the symbol for charge? Q. And so what we're going to do is we are going to fill in our blanks. We're going to fill it in. Q, charge, is equal to 12 coulombs. What's our other number? We also have 4 seconds. So we're going to fill in something equals something, something. So we need, what's our quantity for 4 seconds? What are we measuring? We're measuring time, so that's going to be T. Oh my God, my T's backwards. What's wrong with me? That's a J. There's my T. Okay, there we go. T is equal to, and what goes in the next 2 blanks? 4 and seconds. So you will get full credit only if you write all 3 of those things for each of them. Yes? Now our unknown, you're going to look for the question word. Do you guys know what a question word is? Who, what, when, where, why, how. Also, find or calculate. Okay? Usually it's what or find or calculate. It's going to be something like that. And in this case, it is a very straightforward what. What is the current? So for our unknown, we're going to say, again, we're going to have a blank equals blank blank. What is the symbol for current? I. So we're going to put I equals, and we don't know how much because this is the unknown, so we put a question mark there. And then what is the unit of current? It is amperes, so we're looking for that. So that's our G and our U. Now we're on to E. What does E stand for? E stands for equation. What is the equation? I equals Q over T. What comes after G, U, E? S. What's the first S for? First S is for solve. And remember, when you solve, you get the unknown on the top by itself and on the left. Is I on the top? Yes. Is I by itself? Yes. Is it on the left? Yes, because we haven't really learned how to solve things yet, although many of you could probably do it, okay? It's by itself, it's on the top, on the left, so solve is done, so we don't need to do that. And now we are going to substitute, so we have I equals Q over T. We're going to write that equation, and then where it says Q, we are going to substitute with 12 coulombs. Don't forget your unit, 12 coulombs. Remember units. We're going to substitute, that was supposed to be a green highlighter, not a line. Sorry about that. We're going to substitute T equals 4 seconds. So we're going to put 4 seconds in there. 4 seconds. And then we can easily do the math. It is 12 divided by 4, which is 3. And then our unit is coulombs per second. But we also know that a coulomb per second is the same as an ampere. So we can say that is 3 amps. So we've solved, we've substituted, we've calculated C. We've got our units everywhere. What is B? Box. And last but not least, our last S is we should stop at 2 to 4 digits, or 1 if it's a round number. Like 3 is a round number, right? Okay, it's just like a whole number. Or we should do significant figures. We had in our calculation the numbers 12 and 4. How many sig figs in 12? 2 sig figs. How many sig figs in 4? 1 sig fig. And when we multiply or divide, which is what we did here, we divided. When we multiply or divide, round your answer to the smallest number of sig figs in the calculation. So we should have 1 sig fig in our final answer, which fortunately is exactly what we already have. So it is 3 amps. Is there anyone who wanted a copy of the sig fig thing that did not get one last day? I got 2 more left. Okay, I got 2 people who want them. That's perfect. Okay. And that thing. Who got one last day but did not get an answer key? Anyone else who got the handout but did not get the answer key? Everyone else got it? Okay, cool. Cool. Okay, are we ready? Just about for the next page? If you're moving to the next page, make sure you number it. It's going to be page 33. Okay. Oh, and then we just have exercises. Oh, how nice. So you guys could work on pages 33. Make sure you number these as you are here. Page 33, page 34, and that's it for that. And I'm going to give you guys about 20 minutes to work on that, and then we're going to start something a little bit new. The quiz on this, which will include knowing your quantity, knowing your symbol, knowing your unit, filling those in, but you'll have your purple sheet, right? If you want it. And it will include doing guess cubs without the solve. Okay, so for now, you guys are going to work on pages 33 and 34, 6.2b exercises.
I just gotta be. Yeah. Oh, just drop it.
Yeah.
Hi. I have a question.
Yes.
This one?
Yeah.
Isn't this supposed to be 5? Or
Oh, that's 5
okay,
sig
yeah,
figs.
because it
Yeah.
confused me.
Yeah. That's page 10. I'll fix that.
Okay.
Thank you very much.
Wait,
Yes.
the homework.
Okay. What about number 5?
I thought it was 1 to 4.
Oh, it was 1 to 4.
Yeah.
Yeah, you're right. Sorry.
And then here I have a question.
Yes.
Instead of KGL, am I supposed to be
Nope.
do that to D?
No. D is
keep
the
it.
D is the quantity. The unit is kilograms per liter, and you would want to get rid of that little thing because that means your thing has infinite digits, and you want to stop at a reasonable number of digits. So 10.3.
Thank you.
All right. So first of all, my last day is on Wednesday.
Okay.
So
You'll get what you get done, and then I'll just omit everything else. Okay.
So, how do I write the amount of signals?
How do you write the amount of sig? Did you get the extra enriched stuff?
Yeah. So just
So pardon me?
because what it says for the enriched is just write the line on top.
No, that's not
That's
really what it is. So what it is rounding to the correct number. So you want to show me some of your questions and we'll look at those and figure them out? Hi.
Well, I just have a few questions.
Yeah.
What other do you mean like
Coulombs per second. Yes. Yes.
for this what I just
Yeah.
go
Current equals. Yes. Exactly.
what do you mean for this?
When writing the given and the unknown, you should use the symbol for the quantity and the abbreviation for the unit. Yeah. Hi.
I'm going happy.
Yes, I got that email from you. And when are you gone until?
I'll be back on Monday.
Okay. How are you with algebra? No? Okay. You know what? I'm not going to get too worried about it. Like, if you just want to go and enjoy yourself and then come back and just slot in, that'll be okay. Like, I
Will
think,
that?
no, it won't affect your grade.
Okay.
No, okay?
Okay.
Yeah, I think you should just enjoy yourself. Yeah,
Can we get water?
yeah. Thank you.
Right, so like, for example, over here.
Yeah.
How do I just write one sig fig?
Oh, if you just leave it like that, that's all you need to do.
And it counts as sig.
Yeah, because there's one sig fig. Now here, if we look at, say, this example here, this number has one sig fig. This number has one sig fig. So
Yeah.
your answer should have one sig fig. Okay, and then if we've got this here. Yeah, so, yeah, so anytime you've done and you understand them, do you?
Yeah. The
Okay,
only thing I don't
Yeah.
understand is this one.
okay, don't worry about those ones, we'll get to that when you get to grade 11, okay? We're not gonna have that here, okay? You could just write it like this.
Right.
Okay, yeah.
Like,
Okie
I, like,
dokie?
I know how to do it, just don't
Yeah.
understand why.
Yeah,
Yeah.
don't worry about it.
All right.
Yeah?
Okay.
Okay, cool, yeah. Hi,
I had done the 2 quizzes.
yes,
Have you marked them?
I have marked them and I'll get those back to you right now.
I'm pretty sure I screwed one up.
Okay, friends, I've got quizzes to give back. Oh, look, one of yours is right there. And your other one is right there. Okay, Awani. Ryan is not here. Asma. Logan has left the room without permission. Okay. Fernando has left the room without permission. Arthur. Hmm? Oh, Fernando's over there. Yay, Fernando. Let's give you back your quiz. There we go.
Oh, wait, can I get one of this?
What is that?
Yes. Okay, and we need Evelyn. There you are.
No.
Evelyn. Oscar. Tristan K.
I think it's oh no. I got it all right.
Vova.
Out of 14.
Ella.
Out of 14 because of grad line. Oh, it's just
Ella. Kimmy. Abby. Fernando.
Thank you.
Armando is not here. Tristan L.
Yeah, I got flash now.
Jerry. Jazz. Yaren. Gavin. Yaren.
I couldn't study for it.
Jazz. Yes. Gavin. Tyke. Angela. Oliver. Brian. Awani. There you go. Olivia and Awani, you guys need to write that second quiz, right? Do you want to do that now?
Wait, Tristan, what'd you get?
Lunchtime? Tomorrow flex? Tomorrow flex? Perfect. Okay.
No. What'd you get? I want to talk to you about it. Yeah. 12.5. Well, stupid mistakes.
Huh?
The quizzes?
Yes. Where did you go?
Oh, I went to the bathroom.
Okay. Olivia.
Wait, so you can redo this, right?
Yes.
Что меня трогаешь?
Okay. This one. So just make sure you put that away. Yes. So this one has 1, 2, 3 siblings. This one has 1, 2, 3 siblings. Sure. Yeah, and then make sure you hand in your other part with it, so I know. So if there is a decimal in the number, zeros to the right of non-zeros are. So it doesn't matter where the decimal is, as long as there is a decimal. So if I put a decimal at the end of this number, 5,000 dot, I have 4 zeros. Okay.
My mind blanks over. What's the other thing? I'm not sure.
Hi.
It has an X mark here.
Oh. Well, thank you for being so honest.
Is it real or not real? Oh,
It's
not.
yeah,
Okay.
it should be not, but thank you for being very honest with me. I appreciate that.
Yeah, this one's the wrong thing. I'm sure you should get back. No way. Sorry.
You may. You can go find all the other people and bring them back.
Why do you have like 6 medium lines?
Six 6.2c. Whoops, that was erased and I didn't mean for it to be. 6.2c, page 35. Now, if you are already good at algebra, you don't need to do this my way. You can just do it your way, okay? I'm going to teach one method of solving these problems because I find that if people are not good at algebra, this method makes it easy, okay? It makes it hard to make mistakes as long as you follow the method. So this is called solving the equation. We're only going to be dealing with 3 variables, okay? And we're going to solve for one of those variables. And you'll notice that we only are going to do multiplication and division. There's no addition or subtraction. Okay, so this is like simple algebra. So if we say solve for b, What that means is we want to get B on the top by itself and on the left. Remember, you want your unknown on the top by itself and on the left. And remember, that spells until. And you can use that to help you remember that until you know it by heart. Okay? So we want B on the top. Is B on the top? Yes, B is on the top. So we don't have to do anything for step 1. You have to do these in order. Do top first, then get it by itself, and then get it on the left. Okay? So it's already on the top. Now we're going to get B by itself. So you have to ask yourself, who is cluttering up the B side? Well, we've got this annoying little C down here, right? That's on the same side as B. So we want B all by itself on one side of the equation. And here's the trick. You are allowed to move only diagonally across the equal sign. Okay, only move diagonally and only move across the equal sign. So let's take a look at where we can move C. First thing I like to do is I like to put A over top of a 1 so that you can see that there is indeed a top and a bottom on the left-hand side. Okay, you don't have to put that there if you can imagine it in your head. That's all good. We are going to move C diagonally. You cannot move it. Let's look at the things you cannot do with C. You can't move C down here because that's below the bottom. Okay, you cannot have things that are 2 levels down. You cannot move it across. You cannot move it up. The only way you can move it is diagonally. So it's going to move up beside the A. So we end up with A times C is equal to B. And now we have C beside the A. So now B is by itself. Now we need to get B on the left. Well, wouldn't it be nice if we didn't have these 1s anymore because they're just not really useful. So let's just start by getting rid of the 1s. Okay, let's get rid of the 1s and we end up with B is equal to AC. Now, anytime you have an equation, you can take everything on the left and move it to the right, as long as you take everything that was on the right and move it to the left. So basically you're taking the entire equation and flipping it side to side. Okay, so the B is we're going to flip the entire thing so the B ends up on the left and the A and the C are on the right. And the reason that we want it on the left is because that's going to be really good when we start substituting things in, right? Like if we had something here, we could substitute in our numbers when we start doing the guess cubs with that. Okay, let us try. Actually, just before we do that, you can use 3 tools to solve an equation. See if you can fill in A, B, and C. Get X on the, this is page 36 now. Get X on the top. Get X by itself. Get X on the left. So that's tool number 1. Tool number 2 is you can move 1 or more variables. What direction do you have to move them? Starts with a D. Diagonally. Did you go to your counselor, Logan? Perfect. Okay. Diagonally. Okay. Across the equals sign. So here's just an illustration of what that looks like. If you have X down at the bottom, it can move up to the top on the other side. If it's on the bottom, it can move to the top of the other side. If it's on the top, you can move it to the bottom of the other side. If it's at the top, you can move it to the bottom of the other side. You are not allowed to move a variable up or down. No, 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 no. No, 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 no. You cannot move a variable left or right. No, 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 no. No, 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 no. Only diagonal, not up or down, not left or right. The third thing you can do is you can flip the entire equation from side to side. So xy equals z becomes z equals xy. Let's try a couple more examples. Let us isolate C. That's the same as saying solve for C. We have A equals B over C. We want C on the top. Is C on the top? If it is not on the top, you can move it which direction? Diagonally. Now, if you can see that A is over 1, that's great. You don't have to write that. So C is going to have to move diagonally to the other side. So now the A is going to be beside the C. And that's equal to B. So we got it on the top. What comes after the top? We need C by itself. And this is where, again, it's kind of nice to maybe put these over 1 because you're like, okay, now who is cluttering up the C? The A is cluttering up the C. So we're going to take that A, and which way can we move it? We have to move it diagonally. And the only way to move it diagonally is to move it from the top on one side to the bottom on the other side. So we end up with C is equal to B over A. And lastly, we want C on the left, and guess what? It already is. So we are done with that. And that's it for today. So your homework, finish off 33 and 34, and we'll do more of this solving stuff next day.